All right, the robots are here. And it's up to you to build the future of robotics. You may be interested in adding more automation in your processes due to recent disruptions in the world, like COVID. Or you may have gone to the tech showcase last night, and now you're interested in figuring out ways to add robots into the products that you're delivering. Today, I'm going to share with you some of my experiences in the industry and some key characteristics that I think make for a good robotics product. I'll also be sharing with you some advancements that are happening that you'd be able to take advantage of in your product. So hello, I'm Allison Thaxton, and I'm a roboticist. And I've had the pleasure of working on some of the most advanced robots in the world. I started out in applied research labs, whose goal was to take the state of the art and show the world what was possible. One of my first robots was an underwater robot. And you probably can't tell, but it was about the size of an SUV, and it had a 7-degree manipulator arm attached to it. And we would take it into the harbor, and I would sit at the dock, and we would perform autonomous tasks with it. Navigation and manipulation underwater with varying degrees of human oversight. This later led me to space robots. And remarkably, these two problems had a lot in common. They both had limited bandwidth for communication, and they had the desire to have flexible autonomy that could work in parallel with a human operator. Now, the work that I did with NASA was to understand what it would take to manipulate objects in zero-G. And it's harder than you might think. What was so great about these experiences is that they were applied and they were working in the real world. And that better let us contextualize the progress that we're making and understand its pitfalls. I later started working on home robots. And unlike these super advanced and pretty expensive one-off robots that I'd been working with in these research labs, the home robots needed to be cost-effective. So things like manufacturability came into play. Things like not just selecting the most advanced sensor on the marketplace, but selecting the right one for the task that we were performing. And the work that I did here was around shared autonomy. And we were looking at intuitive ways to have the robot be able to be used in an assistive telepresence with people like the elderly. Now I work on fully autonomous vehicles. First at Neuro, working on delivery robots, and now at Waymo, where we're building the world's most experienced driver for applications ranging anywhere from ride-hailing to trucking. And it's been really amazing to see this progression. Robots have gone from in the lab and super advanced one-offs that really only large government contracts could support to being more commercializable and scalable. And now you'll see them in many industries. In fact, they're in so many industries today. You'll find them in the industrial industry doing things like manufacturing and logistics. And here you'll find them doing things in more and more unstructured tasks. You'll find them in exploration, in space, and sea, and underground. I've seen advances in flexible robots that can make their way into very small holes that humans could never fit into. Things like inside of temples and ruins, telling us a little bit more about our history. You'll find them in the military doing combat support, intelligence gathering, and you'll also find them doing more humanitarian efforts, such as demining or removing mines from battlefields. You'll find them in medical applications, doing minimally invasive surgery, improving patient outcomes. And you'll also find robots that are assisting people, that are giving them more independence. You'll find them in the service industry, doing things like cooking and cleaning, running errands. And you'll also find them in the entertainment industry. You'll see robots in movies, and sometimes the robots are actually real. They're not just props. Movies like Gravity, where you get the effect of actually being in zero-G, wouldn't have been possible without a robot controlling that camera rig. And you'll find them in theme parks, enhancing the user's experience, and in toys for children. So with robots everywhere today, you may think that robots must be the answer for you. Either you're looking to add more automation to your processes because you see competitors doing it and you don't want to get left behind, or maybe, like I mentioned, there have been disruptions in the industry in COVID and you wanted to add more autonomous processes. And I think robots are great. I love robots, but they're not the right solution to every problem. In fact, I think there are 4 characteristics that make for a good problem for a robot to solve. They're precision, consistency, safety, and convenience. And what's important about these characteristics is that you want your problem to have as many of these as possible. The more that you have, the more likely a robot is the right application for you. So let's take a deeper dive into these. First up, precision. And when you think about precision, you probably think about precision engineering. And that's actually a great example. Precision is the quality of being accurate. So if you've ever had the experience of being able to go to a car manufacturing facility, I highly recommend that you do. They do give tours to the public. While I worked at Toyota, I had the privilege of visiting one of these facilities, and it was fantastic. It was inspiring to see such a well-run process in motion, and to see how much and how well robots were able to augment this process. And of course, there are robots there, not just because, right? They're there for a reason. They're there because precision is an important part of the car manufacturing product. You see, what is the difference between a cheap car engine and an expensive car engine is how precise you're able to make it. The more precise you're able to manufacture that engine, the more efficiently it will run, and the better of a product you will make. And so Toyota is continually looking for ways to improve their processes, and have found that robots are a really good solution for this. You can take a task that's labor-intensive, that takes a lot of time for people to do, and you can give it to a robot, and it can do it just as well and quicker. And so if your product requires a high amount of precision, superhuman precision, a robot might be the right solution for you. Now let's think about consistency, or the quality of always behaving or performing in a similar way. Now when I think about consistency, the thing I think about is fast food, right? The burger that you get at a McDonald's in California is exactly the same as the burger that you're going to get at a McDonald's in Las Vegas. And they do this for a reason. This provides the customer a lot of value. In fact, they've grown to be a multi-billion-dollar industry using this model. And if you think about it, the quality of always behaving or performing in the same or similar way, well, that sounds a lot like a robot. And in fact, robots are really good at doing exactly what you tell them to do, exactly the way you tell them to do it, and they can do that over and over and over again. Probably one of my first experiences with consistency with a robot was with doing demos at some of my applied research labs. In fact, the one that I worked at NASA was particularly good at demos. We would have people come by for a demo ranging anywhere from government officials to celebrities. People from and actors from places like the Game of Thrones and Star Trek and Doctor Who would come by our lab, as well as musicians such as members from One Direction or Skrillex. And what we found was that to have a consistent demo, the most consistent demos that we did had the most amount of rigging and the controlling of the environment. So we would do things like put tape marks on the floor or put grooves where we would place these items in the exact same position so that as long as the robot was working that day, you could basically hit play and the robot would perform that demo, and it would do it really well. The demos that were more advanced were the ones that we purposely add a little bit of randomness to it. So we'd do things like randomly place a drill on a table and have the robot pick it up. And of course, it was always the same drill and always the same table. And so really, when it comes to consistency in robotics, the complexity isn't necessarily in the task, it's in the environment. So the more unstructured of an environment your robot needs to work in, the more advanced of a robot you need to make. And so going back to the fast food restaurant, they're able to replicate their process. They're able to replicate their process in each of their stores. And they're able to create these burgers that are the same in each place by doing two things. So let's go through them. One is they strictly control their ingredients, right? The ingredients that each store gets is exactly the same or as close as being the same as possible. And two, they strictly control their process. The way that you assemble a McDonald's burger in one store is the exact same way that you assemble it in another one. And once you start controlling the input and you start having strict processes associated with it, then that becomes much easier for a robot to do. And so today you'll find that there are robotic startups that are looking to fully automate things like fast food. Next, safety. I think safety is one of these areas that robots can actually have a huge positive effect in. If you think about safety, robots are always vigilant. They're always watching. And they always do exactly the same thing that you tell them to do. So they don't really have this human error aspect to it, right? And so they're great for layering on top of human actions and providing an extra layer of safety. And a great example of this is the advanced driver active safety systems that you might find in your car, right? Cars that have these types of systems, they're able to put on the brakes in imminent collisions before a person might be able to react to do it, and they're safer because of that. They're much safer than cars that only have seat belts. But still today, there are about 1.3 million car fatalities worldwide every year, and a large portion of those are caused by human error. So there's lots of opportunity here to make driving safer. And indeed, that's one of the key tenets that Waymo is trying to do, is trying to make the world safer by using autonomous vehicles. And I've had the pleasure of riding in one of these autonomous vehicles without having anyone in the driver's seat. And let me tell you, that experience was awesome. But after the initial thrill of being in a car that nobody's driving and it's driving around, it actually gets a little bit boring. And that's exactly what you want when it comes to safety. You want your car to understand the world around it and react to things before they become issues, so that your ride is safe and you can get from one place to another with the least amount of drama as possible. And sitting in that car, I felt, really proud because I was a part of making it. But I also felt really confident in its ability to do that job because I know the amount of testing that went into that ride. And I think if safety is a critical component to your product, that you're going to need similar amounts of testing. At Waymo, we've developed testing frameworks to do this, safety methodologies, we've attained safety certifications, and you'll also need to be able to replicate what happens on the road in a simulator. So if you're looking to add safety to one of your products, you're going to want to look at what you can do to test your robot. Finally, let's take a look at convenience. Now, when you think about convenience, you probably think about convenience or the ability of making things easier to do, something that's useful and helpful. You probably think about things that might help you around the house. And I certainly do, things that will mow your lawn for you so you don't have to, things that will vacuum your home. And indeed, I have a robotic product in my house that provides me convenience, and it's a robotic vacuum. Now, I hate vacuuming, and so actually, in convenience, it's adding a lot to my life. And the value proposition isn't just that now I never need to vacuum my home again. It's that because I disliked doing it, I wasn't doing it enough. And so adding a robot vacuum into my life means that any amount that it's able to do in the net means my home is getting vacuumed more than it was before. And so the value proposition here for me is pretty high. And when you think about convenience, you really want to think about the value proposition that you are adding. You'll want to think about what are some viable alternatives that your customers could use instead of your product. So for things like the home robot vacuum, right, the viable alternatives here are hiring a maid service. And maid services are great, and they do a lot more than just vacuum your home, but they're also quite expensive. And so there's a price point here that you have to meet in order to provide that value. And robot vacuums are able to do that. Other things might have a higher quality bar that they need to hit in order to provide value. So if you think about something like cooking in your house, right? Like, I don't like cooking, maybe I'll get a robot to do that. The thing is, a half-done meal is probably not one that you can eat, right? Unlike a half-vacuumed home, that's a more vacuumed home, right? So the value, the quality that you have to provide with that product is higher. And there's also a lot of cheap, viable alternatives. If you don't like cooking in your home, you always have the option of ordering out. So you really have to be cognizant about what are the viable alternatives when you think about convenience as a key characteristic of your product. So we've been over the 4 characteristics. Now let's go into a case study. First, I'm going to look at space robots as a case study and talking about Robonaut. Now, I know Robonaut was more of a research platform than an actual product, but let's go through this exercise. What is Robonaut? Robonaut was a humanoid robot and was on the International Space Station doing dexterous tasks. You may be wondering why we put such a complicated robot on the space station. Well, it was meant to do sort of maintenance tasks inside of the space station, and we made it humanoid because it was meant to use the tools that were already on station. Now, why not make a robot that has custom tooling? The reason is that you'd have to certify every single tool that gets flown, and there was already a whole tool set on the station, right? The station was built for people, it has human tools, and all of the maintenance tasks were things that people could do. And it was flown onto the station in 2011 and was later upgraded in 2014. So let's go through each of these characteristics and see if Robonaut meets any of them. First up, precision. Do you need superhuman precision in order to do the task that Robonaut was designed for? No. It's human-like precision, human-like tools, doing human-like tasks. So we don't really need superhuman precision here. What about consistency? Robonaut was built to operate in a remote location on the International Space Station. So consistency is kind of important. You need it to be reliable. And there's 2 things that I talked about that can make consistency easier for a robot to attain. 1 is controlling the inputs, and 2 is having strict processes. And it turns out both of these are actually true for the space station. Every single tool is certified and gets launched onto the station. We know exactly what's there. The Robonaut only has to be able to work with a particular drill, not every single drill in existence. And so we can control the inputs here. What about strict processes? Yes. Astronauts follow pages and pages of procedures for almost everything they do on station, including the maintenance tasks. So there are strict processes that astronauts are already following for these tasks. So we have both of these things. We have controllable inputs and processes that it needs to follow. What about safety? Now, when I was on this project, we talked a lot about safety, and we made sure that the robot was safe to be around the crew. But notably, this isn't actually adding any overall safety to the system. It's just not diminishing safety. So while the robot was 2-factor safety certified to operate in this tiny capsule with astronauts present, so we know that the astronauts weren't going to get hurt, it wasn't actually adding anything more in terms of safety for the entire system, right? Notably, I think this would drastically change if Robonaut was designed to be outside of the designed to be outside of the space station. Because one of the most dangerous tasks that an astronaut has to do is a spacewalk. And any amount of time that they have to spend outside of the relative safety of that capsule is inherently dangerous. So if something like Robonaut could have saved them that time, and it would have increased the amount of safety in the system. Now, what about convenience? Like I mentioned, a lot of the tasks that we had Robonaut do were maintenance tasks. They were meant to be more convenient for the astronauts on station. And when I talk about convenience, I mentioned you have to look at your viable alternatives. And the thing is, being on the space station, there's not really that many viable alternatives, right? You have the astronauts, and you have a robot. And so you're really just competing with astronaut time. And it turns out astronaut time is very, very expensive. So I think we were able to capture some of the convenience aspects. So when you look at these 4 characteristics, you see Robonaut captures consistency and convenience, so 2 out of 4. Not bad. But I think we can do better. Let's look at autonomous vehicles providing a ride-hailing service like those that Waymo provides. Now, Waymo is an autonomous driving technology company. It was started in 2009 as the Google self-driving car project, and later became its own subsidiary within the Alphabet ecosystem. And it is currently providing fully autonomous rides with no driver in the driver's seat in both Phoenix and San Francisco. Let's go through these 4 characteristics. Precision. You kind of just need human-like precision. It doesn't require superhuman precision to drive on a road. If you stop within a millimeter of the stop sign, you're not going to get any more safety or get any more driving quality than if you were within a couple inches. You need human-like tolerances. What about consistency? Yes, you need a highly consistent product. And I talked about inputs and processes related to this. Can you control the inputs in a ride-hailing service? Yes, you can. You can geofence where you go. You can time block when you are active. You can have restrictions on weather, so you can control the inputs. Can you control the process, or are there strict processes? Yes, there are road rules. And autonomous vehicles would be better at following road rules than a human driver. So just adding value there. What about safety? I've already talked a lot about safety. We're building the world's most experienced driver. I think this is an area Waymo can do well in. What about convenience? Ride-hailing has shown us that convenience is something people will switch their habits for. And so we're looking at viable alternatives. Waymo will be competing with other ride-hailing companies. But because there's no human in the driver's seat, we believe we can do it at a better price point. So we get 3 of the 4. It's better, right? But let's talk about some new technologies that are coming down the market, coming out, things that you can take advantage in your new product. First, let's talk about simulation tools. And I think simulation is one of those areas that robots can really benefit from. There's a huge amount of investment in the industry in VR and AR technologies. These are developing simulation frameworks that then your robot can use to better understand the world, and your engineers can use to build better models. With better replication of the real world through these simulations, you can create synthetic data, getting coverage and testing over things that would be harder to do in the real world, or cover gaps that you might have in your data. And also, you can take advantage of things that are coming out that improve compute per watt, things like GPUs and TPUs that allow your robot to do more advanced operations for cheaper, getting more of that convenience. Next, I think you'll be leveraging more data. There's already been a lot of benefits in these large ML models that have come out, but a model doesn't work that well without a lot of data associated with it. And so it's not just the data. It's, do you have the right data? Have you labeled it appropriately? Can you analyze it? Do you know how it's distributed? Can you make some determinations like that along your data? You'll also want monitoring tools. As you continue to gather more data, you're going to want to know, is your distribution shifting? And if so, why? And what can you do about it? And finally, I think the thing that will that will help us the most is as things are becoming more automated, code is being generated, models are being automatically generated, you're going to have to worry about things like ethics in the things that you're creating. You're going to want to remove the biases and ensure that your data represents the world. Finally, I think we'll see advancements, and we've already seen a lot of advances in this, in human understanding. You're going to want your robot to understand people. What are they doing? What will they do next? Behavior prediction. You're going to want them to understand what people are trying to communicate, gesture recognition, and natural language processing. And all of these things together will enable your robot to interact with people in a much better way. And you'll need this in a whole bunch of industries. You'll need this in home robots and things that consumers will use, and you'll also need this in anything that your workers are interfacing with in the factory. And so I'll leave you with this challenge. Go build the future of robotics. Use the things you learned today about what makes a good problem for a robot to solve, and go solve them. Use some of the advances that are coming out in the marketplace to your advantage. And above all, build robots that help people. Thank you. Thank you, everyone. If you want to find more about me, you can visit my website, AllisonThaxton.com, or if you want to chat more about this, I'll be in the hall, and then I'll make my way to food and eating.